So we have a function, we have a point, and we are asked to find the slope of the tangent line, this tangent line here, at the point p comma p negative 3 comma 4. What will that be? How do we determine the slope of the tangent line to the graph of this function at that point, or the instantaneous rate of change? So please contribute even if you're wrong. It's okay. How do we determine the slope of the tangent line at that point, which is the same with the instantaneous rate of change?
The sorry, I lost my train of thought.
That's okay.
The derivative of the function at -3.
Excellent. Thank you very much. That is the slope. Awesome. The second derivative tells all of these about the function. What? What does the second derivative tell us about the function? What does it give? If you don't like tells, give. What information we get from the second derivative about the function? Anyone? I know we didn't get the chance to look at an example, but what are the two very important pieces of information that the second derivative gives? We know about the first derivative. Increasing, decreasing intervals, critical numbers, max, min.
Points of inflection?
Yes, very good. Points of inflection. We did not get the chance to last time to determine any. We're going to start with this today. And one more piece of information.
Concavities?
Yes. So if it holds water or it does not. And we were going to analyze what's happening there. Awesome. Thank you. Concavity. And I'll explain when this happens, when this or this. Okay, last question here. A function can or cannot have a max min where it is not differentiable. It can or it cannot. Of course, assuming it exists there, right? F of x is defined there and continuous. It can or cannot. What do you think?
Cannot.
Okay. Okay, let's go back. The function is not differentiable at this point, but it has a minimum. As long as the function is continuous and it exists there, in other words. Here, the function is not differentiable. F prime is undefined. So at this point, the function is not differentiable, but it's continuous. It exists and it's continuous, and it has a maximum, a relative max, of course. So we will have to circle can. But of course, with this piece of information, is defined and continuous. Okay, so it can. So a function can have a max. Yes, go ahead, please. Any questions? Mike, did you want to say something?
Oh, no, I was just saying thank you, Trivia. I missed that part about it being continuous.
Right, right. So that's why I don't mind. I'm begging students to redo the notes and look at each and every one of them and make your own notes on the side. It's invaluable piece of information. Okay, good. So now let's answer your questions, and then we'll go back to this problem. So actually, I need the page prior to this as well. I'm going to keep both. Okay, so, or I start from scratch and I just copy it. Maybe that's the best. So any questions? Do you need help with anything? Do you need help with anything? Pearson, anything? Anyone? Anyone? Anyone, please?
I have a question about the homework.
Yes, anything.
For number 72 on page 278, were we supposed to, when we did the
72
table, were we supposed to,
1, 2, 78?
Yeah.
Okay.
for when we did the table, we're supposed to put t between 0 and 12, since it said
To be honest, I did not write the solutions. As you know, I write the solutions afterwards. Let me look at page 278 and copy the problem. Let's work on it. Oh, the temperature during an illness. Okay. Of a person, okay. So we have T of T. I don't really like T of T, but anyway. -1 T squared plus 1.2 T plus 98.6. And T is between 0 and 12. And T is at the temperature, of course, this is in degrees Fahrenheit, and this is days. Okay. Find the relative extrema and sketch a graph. Don't sketch the graph, right? We are not there yet. So we are asked to find the relative extrema. This is the plural for extremum. In other words, find max or find min or both. Okay? So now please ask your question again, and then I will work through the problem so it's clear for everyone, to everyone on.
when we
Yes.
made the table,
Yes.
were we supposed to put t between 0 and 12?
Yes. Very
Okay.
good point. Yes. So I have t 0 to 12, t prime of t, and t of t. Yes. So let's do that. Since it's a polynomial, when I find t prime of t, I will get -0.2 t plus 1.2. And we have two options here. Either it's 0 or it's undefined. And we know this is a polynomial. This is not possible. But we have to check. So now when I set this equal to 0, I have -0.2 t equals -1.2. And t will be 12 divided by 2, which is 6. So I put the 6 in the table. I put 0 immediately for t prime right here. And now I have to study the sign left and right. When I plug in 0 in the derivative, I get positive. When I plug in 10, I get here -2 plus 1.2. So this is negative. At the next point, the next step, I have to plug in 0 in the function. I have to plug in 6 in the function. I have to plug in 12 in the function. This is the function. So with the graphing calculator, put in y equals, okay, here it is, and we have -0.1 t squared, and then plus 1.2 t, and plus 98.6. And then easily plug in those numbers that I need, only those, 0, 6, and 12. So go back up, 98.6, of course, 102.2, and 98.6. So at this point, they're asking us to find a relative extrema. I need to explain one very important thing. If I have, for example, this function, as you see it here, it starts at a point, it ends at a point. In other words, it does not go on forever. For example, this goes on forever. No, it starts at this point and it ends at this point. These points, the endpoints, cannot be relative. Only a point where the function exists left and right can be a relative. So this is a minimum. So it's a relative minimum. But this one can never be relative because it's at the endpoint of the interval and I cannot show the function on both sides. This one can never be a relative, max or min, because I cannot show the function on both sides. See, here the function exists on both sides. That's why this is a relative. This one will not be anything because there are points lower than it and points higher than it. But this one happens to be the top. We will call this one an absolute max. Of course, we use two different words, absolute or global. So for this function, this is the absolute or global maximum, but it cannot be relative because it's at the end point. This is nothing because there are values lower and values higher than it. And this is the absolute minimum and relative minimum because there is no other value smaller than it. Okay, so this is the absolute minimum, and this is nothing. So when we are asked to find the relative extrema, we are only asked to find points inside the interval, not the end points. So now we need to make sure that these two rows work well, or they are in sync. This is when I catch my mistakes. Let's see. From 98.6 to 102.2, what does the function do? From 9, yes. So I'll put an increasing here, but I verify. Is this supported by the sign of the first derivative? Yes, it is. Awesome. From 102.2 to 98.6, what does the function do? Oh, awesome. Is that supported by the sign of the first derivative?
Yes.
Yes. So this 0.6, 102.2, it's the relative, but for this situation is also the absolute max. There is nothing higher than it. But we haven't really discussed, you're not asked to discuss the absolute. We're going to have a special section for it very soon, hopefully today. Does that answer your question on this?
Yeah, thank you.
Thank you. Very good. Awesome. Other questions for me? So that's how we know whether our calculations are correct or not. If these numbers do not fit the signs of the derivative, then we say, oops, something is wrong. We go back to the drawing board. Okay, perfect. Now let's go back to this problem. I'm going to copy it again. So this is from 3.2. And the problem was number 13. And this is h prime of x equals 3x squared minus 27. We determined the second derivative to be 6x. We set h prime equal to 0, and we obtained plus or minus 3. And I'm going to copy the table. And the table with h prime, h of x in the middle, and the second derivative. We know the domain is all real numbers, and we plug in -3. 0 has to be in the table, and 3. So we have 0 here and 0 here. We already established the sign of the first derivative. So it was positive, negative, and positive. And now I can put that away. And now I have to determine these values for the function, which I did not copy. Okay. So of course I will put it in the graphing calculator. I just need 1 second to change. I created the discussion, but I just want to delay it a little bit. So I'm just going there to not let it open just yet, because I want to finish this. So I am just waiting. So I just want to de-highlight that. That's all I wanted to do. Okay, I did. So where are you? Where am I? Okay, I'm doing this. Okay, so in y equals, we clear, and I have x cubed. Don't forget to come down from there. Minus 27x. Okay, and I will plug in exactly what I need. I need a -3. Oops, no. I need -3. Of course, I need 0, and I need 3. And I copy 54. I copy 0, of course, and -54. Okay, so also I would like to see what happens to the function when x approaches -infinity and when x approaches infinity. So look at this function. And remember, we talked about limits. Which of these two terms is the most powerful at infinity or -infinity? Which of these two is the strongest? If I have -3, I have to plug in everywhere, or 0 or 3. But when I talk about infinities, which of these two terms is the strongest? It will dictate, for sure. Anyone? Please, give it a shot.
X third.
Of course. Of course. So now, in x to the third, plug in -infinity and tell me what I should write here. In x to the third, plug in infinity and tell me what I should write here. That's how we determine the limits for this function. I'm trying to adjust here so I can also, the other camera works well. So when you plug in -infinity here, what will you tell me to write? When you plug in infinity here, what will you tell me to write?
-infinity, infinity.
Of course, very clear. At this point, this is the moment of truth. This is when I know and find my mistakes. This is when I try to make sure, or I verify, that these two rows are in sync. If they're not in sync, I have a mistake, I have to go back. So, from -infinity to 54, what does the function do?
Increase.
Good. Is this supported by the sign of the first derivative?
Yes.
Perfect. From 54 to 0 and 0 to -54, what does the function do?
Decrease.
Yes. Is this supported by the sign of the derivative?
Yes.
Excellent. And finally, from -54 to infinity, what does the...
Increase.
Yes. Is this supported by the sign of the first derivative?
Yes.
Excellent. So then these two work well together. Now, we have to identify this point, -3, 54. Of course, this is the x and y intercept. But negative 354, what type of point it is, and 3 negative 54, what type of point is that? The first one. What do you think? Yes. The arrows tell me exactly what it is. Exactly. So this is a relative max. What about 3 comma negative 54? Not 3, 0. This is the derivative. The point is 3 negative 54.
Relative min.
Yes. It is indeed a